Hi there everyone, and welcome back to week 13 of the Maths Tutor exam countdown. So as you can see from the heading there, this week is all about trigonometry. And I have linked two very good useful videos in the chat, one on an exam question on trig identities and equations, solving trig equations. And the second one is the derivation of the cosine rule, which is a requirement of your course. So those of you that are full members, you have obviously access to all of the proofs that are required for trigonometry and every other topic as well on the Maths Tutor website. Okay, let's jump straight in. And I've just put up here on the screen, just to remind you, you have your 4 pages, 13, 14, 15 and 16 in the log tables that are going to be quite useful to you. So I'm not going to go through them in too much detail, but I suppose you have all of your identities there, 13, 14 and 15. You have your identities there, some more popular than others. So that cos squared plus sine squared a equals 1. That's quite a popular one. Some that you'll come across more often than others. But obviously all of your proofs are required for those as well. And then if we go to page 16, you have a lot of your formulae. So you have your area formula, you have your sine rule, and you have your cosine rule formula. And then you have your sine, cos, and tan. And you may have learned sine, cos, and tan using various mnemonics, SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So you may not actually use your log tables for these three at all, but they're there if you require them. And you have your Pythagoras Theorem obviously as well for obviously just right angled triangles, whereas these up here at the top of page 16, they can be used for any type of a triangle, as you can see from the diagram there. Okay, so we're going to jump straight in, and first of all I'm just going to show you this very, very simple flow chart, which basically goes through how to go about attempting a trigonometry question in an exam. Okay, so the first question I would ask myself is your triangle right angled? Okay, if you answer yes to that question, you're obviously going down the route of sine, cos and tan if we have anything to do with angles, or Pythagoras if we know two sides of the right angle triangle and we're looking for the third. If your answer to that question was no, then you need to ask yourself, do I know one side, the opposite angle, and one other piece of information? So just to show you a diagram, what I mean by that is, just for example, if we had this side here A, and we knew this side here B, and we knew the opposite angle. So you'll see from my diagram, angle A is opposite the side A, and yes, I know one side, I know the opposite angle, and I know one other side. In that case, to find another side or another angle in that triangle, we would use the sine rule, okay? And that's again coming from page 16 of your log tables. And remember, this is even if the triangles are not right angled. So if you've answered no to that first question, the sine rule is fine. And if you've answered no to this question here, well then your last resort, I suppose, is your cosine rule. So for solving triangles, I think that flow chart can come in quite useful, and you're going to see it, you're going to see me using it as we go through some of the exam questions to come as well. Okay, so we're going to go straight into an exam question then. We're going to start with a very recent one, so last year's 2021, paper 2, and it's one of the long questions, question 7. So this was a 50-mark question. It was one of the optional from section B of the paper. You needed to answer any 2 of these questions. So the diagram shows the 3 sections of a level triathlon course. In order to complete the triathlon, each contestant must swim 4 kilometers from C to B. So I'm just going to mark that in on my diagram. That distance there is going to be 4 kilometers. Cycle then from B to A, and then run 28 kilometers from A to C. So again, just marking the information given to me in the question in on my diagram. Mary can cycle at an average speed of 25 kilometers per hour, and it takes her 1 hour and 12 minutes to cycle from B to A. So we're asked to show that the total length of the course, so that's the swim, the run, and the cycle, is 62 kilometers. So we're going to need to use our dad's silly triangle, or our distance, speed and time here. And we're basically looking for the distance. We know the distance here from A to C, and we know the distance from B to C, and it's this distance here, A to B, that we're looking for. But what we do know is we know that the speed that she can cycle at is 25 kilometers per hour, and we also know that the time it takes her is 1 hour and 12 minutes. So using Dad's silly triangle, your distance is going to be speed times time. So taking my speed of 25, so my distance is AB, is what I'm looking for. It's going to be my speed times my time. And 1 hour 12 minutes, sorry, that should be a multiplication symbol. 1 hour 12 minutes is equivalent to 1.2 hours. So if you're unsure where I'm getting that from, well, I'm just working out what 12 minutes is as a fraction of 1 hour. So 12 over 60 is 1/5 as a fraction, or as a decimal 0.2. So that's where I'm getting the 1.2 here. And it's just a matter of multiplying the two of those together, and that will give me the distance from A to B. And I can mark that in up here on my diagram. That's going to be a distance of 30 kilometers. Now, they've asked in the question for the total length of the course, so that's just a matter of me adding my 28 plus my 4 plus my 30, which adds to 62 kilometers, as we were told in the question, as we expected. Okay, so nice and simple using distance, speed and time there. Part 2, or part B. On average, Mary can run 5.6 times as fast as she can swim. It takes her 4.8 hours to complete the course. Find her average swimming speed in kilometers per hour. So first of all, I'm going to start with that 4.8 hours here. It takes her 4.8 hours to complete the full course. So we already know that it takes her 1.2 hours, or 1 hour and 12 minutes, to do the cycling part. So if we first of all subtract 4.8 minus our 1.2, well, then we know that it takes her 3.6 hours, and this is to complete her run and her swim. Okay, so again, we're going to be using Dad's silly triangle here. This time we are looking for her swimming speed. So we're actually going to introduce a variable here. We're going to let x equal her swim speed, because that's what we're looking for, I suppose. And because we know a good bit about time, we know how long it takes her to complete the run and the swim, we're actually going to use our Dad's silly triangle up here. We're going to try figure out what time is. So you can see there that if you covered the T with your hand, you're left with your time is distance divided by speed. So let's take the time that it takes her to run and the time that it takes her to swim. So if we take the time that it takes her to run, first of all, well, that's going to be the distance that she's running, which is 28, as we're told at the top of the question, divided by her running speed. And we know that she can run at 5.6 times as fast as she can swim. We were told that here. So that's just going to be 5.6 times x. We're also going to add to that the time that it takes her to swim. So we know that the distance from her swim, if we go back up here, this one was her swim from C to B, that's 4. And we said that x is her swimming speed. So that's 4 over x. And we know that when we add those two together, we should be getting 3.6. Okay, so just to recap on that, we are using our Dad's silly triangle to find the time, because we already know that the time is 3.6. So we're going to work out the time it takes her to run, which is distance of the run is 28, over the speed of the run is 5.6 times her swim speed, plus 4 is her distance for the swim, and the speed for her swim is going to be x, okay? And from there, I haven't left myself a whole lot of space, but we're just going to solve that equation. And how we're going to solve it is we're going to look for, first of all, a common denominator. So you can see from the left-hand side there, your common denominator of the two fractions is going to be 5.6x. And what you're left with on top is 28 plus 4 times 5.6, and on the right hand side we've gotten 3.6. Okay, so my common denominator again coming from here, and then I've worked out my top line. So on top, that's going to give you 28 plus 4 times 5.6, so that gives you 50.4. On the bottom, it's 5.6x, and on the right, it's 3.6 over 1, if you like. So what we've got here is one fraction equal to another. We're going to do our cross multiplying. So it's 5.6x by 3.6, so the bottom left by the top right, and that will give you 20.16x, and top left by the bottom right is just giving me 50.4. So to find x, we're going to divide 50.4 by 20.16, and you should be getting 2.5. Remember, it's kilometers per hour because it's an average speed, and they're giving you the units there as well. Okay, so moving on to part C. So this is where it gets to trigonometry, I suppose. We're asked to show that the angle ACB, so remember you're always looking at the letter in the middle there to tell you which angle exactly it is 116.5 degrees to 1 decimal place. So the first thing to make sure here is your answer needs to be in degrees. So make sure that your calculator is in degrees for this one. So if we just go back to our diagram for a second, and we'll have a look, they have it marked there for us, but it's that angle that we're looking for. So think about your flow chart. The first question was, is this triangle right angled? So we've answered no. So if we go back up here, is the triangle right angled? We've answered no, so we're heading in this direction. Do I know one side, the opposite angle, and one other piece of information? So have a look. All you know about that triangle are the 3 sides. So again, we're answering no to this question. So in this case, we know that it's going to be the cosine rule. Okay, so I'm going to page 16 of my log tables. I'm going to write down my cosine rule. So taking that from page 16, and a big mistake that's made with cosine rule, and a big thing to remember, is that whatever side is at the start, that has to be the angle, it has to be corresponding to the angle at the end. Okay, so if we go back to our diagram here, and because it's this angle here that we're looking for, well then we have to start with this side. So that has to be my A, and then B and C, it doesn't really matter which is which. Okay. So my A is 30, my B is 28, and my C is 4. So subbing in, that's going to be 30 squared equals 28 squared plus 4 squared minus 2 times 28 times 4 times the cos of angle A. And we can put 30 squared into our calculator. That's going to give us 900. We can put 28 squared into our calculator is 784. 4 squared is 16. And just be very, very careful here. Please don't throw that all into the calculator together. The reason you can't do that is because look at this part over here. So if you look at this part here, sorry, I've gotten rid of a little bit of that too. That is multiplied by a cos A. So if you had something like this, if you had 5 minus 4x, you wouldn't dream of putting those together to give you 1x. So it's pretty much the same thing here. This has a cos A on tagging along the end of it there. So we can't just put the whole thing into the calculator. So 2 by 28 by 4, that's going to give me 224, and I have a cos A. So absolutely put these two together and subtract them at the left-hand side. So that should be giving you 100. So we're getting 100 equals minus 224 times the cos of A. We're going to divide across by minus 224. And we should be getting the cos of A, just going to switch sides here, is minus 25 over 56. And the last thing, the thing that we're trying to get on its own, is this angle here. So we're going to get the cos inverse of both sides. So that will give me A is equal to the cos inverse of minus 25 over 56. And throwing that into your calculator, you should be getting 116.5 degrees. And again, like I said, make sure your calculator is in degrees. And that's to 1 decimal place as we were asked in the question. Okay? Part D then, to comply with safety regulations, the region inside the triangular course must be kept clear of people. Find the area of this region and give your answer in kilometres squared, correct to 1 decimal place. So straight away, we have 2 formulas that we know for area. The first one is, half the base times the perpendicular height. And the second one is coming from page 16 of our log table. It's half AB sine C, where A and B, those are any 2 sides, and the C, as you can see from the diagram on page 16 of your log table, it has to be the included angle, the angle in the middle. Okay, so if we just go back up to our diagram, we're going to decide just tidy this up a little bit. We're going to decide which of those formula we're going to use. I suppose we can mark in here that we found this angle was 116.5 degrees. And you can clearly see there, we don't have a clear base and a perpendicular height. So it has to be the half AB sine C that we're going to be using. Okay, so just get rid of those labels as well because they were relevant to the cosine rule. What we're going to use in this case, we're going to use this is going to be our A, this is going to be our B. Why? Well, because this is the only angle we have, so we have to use that angle. So 30 is not being used. So it's going to be, subbing into this formula, our area is a half of 28 times 4 times the sine of the angle in between, which we've just worked out in part C, was 116.5 degrees. And you're just throwing that straight into your calculator, and to 1 decimal place we should be getting 50.1. Don't forget your units, they're giving them to you there in the question, 50.1 kilometres squared. Okay, and finally part E, find the shortest distance from the point C to the side AB. So if we go back up to our diagram, the shortest distance, again, I'm just going to tidy that up a little bit. And we know this is 116.5. So the shortest distance we know is always going to be your perpendicular distance. Okay, so I'm just going to mark that in my diagram. And we're basically looking for that distance, that blue line that I've marked in there. But what we know from part D is we know that area of the triangle, regardless of which of the formula that you use, your area is going to be 50.1. So all we're going to do in part D is we're going to use that other formula. So this half the base by the height, we're going to use that down here in part E, and we're going to fill in as much as we possibly can into the formula. So we know from part D that our area is 50.1. It's still the same triangle, we're just using a different formula. A half is just a constant. If I go back to my diagram here very quickly, you'll see that the base that we're using is this one here, and we're using this as our perpendicular height. So that's going to be, your base is going to be 30. And I'm just going to call the height X for now. That's what we're looking for. So that should be fairly straightforward. That's going to give me 50.1 is equal to 15 times X. And that should tell us when we divide both sides by 15 that X is 3.3 and our units are kilometres in this case. Okay, so always a good idea to maybe go back to your diagram and just fill it in because you don't know where you're going to use that later on. You may or may not use it. It's a good habit to get into. Okay, so last part of this question then is kind of a 3D problem, I suppose. You need a little bit of an imagination in this case. The course is viewed from a camera tower, which rises vertically from the point A. So you can see you can see there that that's your tower. The top of the tower is point T, and the angle of elevation of T from B is 0.05 degrees. So I'm just going to mark that in the diagram. We're coming from B, and we imagine that we're standing at B, and we're looking up here at T, and that angle there is going to be really small, 0.05 degrees. Now, remember that A, B, and C are a triathlon park or triathlon circuit, I suppose. So they're all on level ground. So I can also mark in that this angle here, so TAC, that's going to be a 90-degree angle. And there's a couple of other things. If we I suppose if I just draw it out here for you to make it a little bit easier, sometimes that helps with these 3D problems. So there's T, A, and B. Sorry, I meant T, A, B the last time. And I'm just going to mark in what we know. Well, we know this angle in here, that's 0.05 degrees. And we also know that this length here, from our previous diagram, is 30 kilometers. And what we're looking for in this part of the question is the distance from A to T. So I'm just going to mark that with an X. That's what we're looking for. And remember, we said because the triathlon park or circuit is on level ground and the tower rises vertically from the point A, well then we obviously have a 90-degree angle there. So back to our flowchart, if you like. First question you ask yourself, is this a right angle triangle? In this case it is. So we know we're either going down the road of sine, cos and tan or Pythagoras' theorem. Pythagoras is really only useful if you have two sides of the right angle triangle and you're looking for the third. So here it has to be sine, cos and tan. A really good habit to get into is look at your triangle and label exactly what you have or what you're looking to find out. So if you like it, here, there's my angle and this is opposite it and this is adjacent meaning it's beside. So we don't really know anything about the hypotenuse, nor are we interested in finding anything out about the hypotenuse. So if I just remind myself of SOHCAHTOA, clearly see, because we have, or we're looking for O and we have A, it's tan that we're using. So you're asking yourself tan of what angle? Well, it's tan of the only angle that we have, 0.05 degrees. It's going to be the opposite, which is X, over the adjacent, which is 30. Okay, and you're just going to solve that equation. X is what you're looking for. The 30 is dividing by it, so it's in the way. So we're going to multiply both sides by 30, and that will give me 30 times the tan of 0.05 degrees gives me X. And throwing that straight into your calculator, you're getting 0.026, but remember, those are kilometers. We were asked to give our answer to the nearest meter. So all we're doing is we're multiplying this by 1,000 because kilo means 1,000 and there are 1,000 meters in a kilometer. So the height of your television tower in this case, or your camera tower, is 26 meters. Okay, so you see the use of that flowchart there. We used it a little bit just in that part F, and we also used it a little bit in part C with the cosine rule. Okay, so moving on to another very recent question, was 2020 paper 2, and this was question 4. So there was a trig identity to start with, and then hopefully we'll get time to get to this sector at the end as well. So find the two values, so we're expecting two answers of theta for which this equation, this trig equation, is true, and your answers need to be between 0 and 4 pi. So straight away when I see pi in the question, I know my calculator needs to go to radians, so you're changing your calculator first off. Okay, so you might remember your ACTS or your CAST, whatever way you learned it, unit circle, and that basically tells us which quadrants our answers are going to be in. So the very first thing we do here is we find what we call our reference angle, and that's going to lead us through the rest of the question. How we do it is we take our equation and we find what the reference angle for theta over 2 is. In this case, we're finding the tan inverse of 1 over root 3. So you'll notice I haven't put in the minus. I haven't put this minus in there because by me deciding which quadrants over here, by me deciding which quadrants my answers are in, I've taken care of that minus. So theta over 2 is tan inverse of 1 over root 3. That just goes straight into your calculator and you should be getting a reference angle of pi over 6. So in this case, that is going to be pi over 6 in this quadrant and in this quadrant because we're interested in where tan is negative. So tan, we have a negative here. So sine is positive in the S quadrant and cos is the only one that's positive in the C quadrant. So that's why I'm choosing those two quadrants. So if I take this quadrant, for example, we're always going, remember, from the x-axis, so we're always going from this axis. In here, my angle is going to be 180 degrees, or pi in radians. minus pi over 6. And if I go in this quadrant, it's going to be 2 pi, which would be a full circle, and minus your reference angle of pi over 6. So your first angle is basically there, and your second one is going to be there. So theta over 2 is going to be pi minus pi over 6 for that first quadrant, and then my second answer is going to come from 2 pi minus pi over 6 for my second quadrant. So throwing that into the calculator, pi minus pi over 6, that's going to give you 5 pi over 6. And 2 pi minus pi over 6, that's going to give you 11 pi over 6. But remember, that's theta over 2 is 5 pi over 6. Add on your 2n pi. Where does that come from? Well, remind yourself that we can actually go around this unit circle as many times as we want. So we add on n, as many as we want, of 2 pi's, which is just your 360 degrees. So 2n pi. And then the very last thing we do is, or the second last thing we do, because there's a 2 here, dividing, we multiply across by 2 because it's theta that we're looking for, values of theta. So that is going to give me, theta is 5 pi over 3 plus 4n pi, and theta is 11 pi over 3 plus 4n pi. So the reason I added this 2n pi in here is because when we're getting rid of this 2 here, we also have to multiply this part, the 2n pi, by 2 as well, okay? And the very last thing that we do is we sub in our values of n, and we always start with n equals 0. We continue for n equals 1, n equals 2, once we don't pass out your domain here, which is 4 pi. So we're going to start with n equals 0, and we're going to sub it in here, and we're going to sub it in here. So that will give me theta is 5 pi over 3 plus 4 times 0 pi, and this will give me 11 pi over 3 plus 4 times 0 pi as well. And that basically crosses off this term and this term, so those are your two values of pi. So we have 5 pi over 3, and we have 11 pi over 3, and we can't go any further, obviously, so we can't let n equals 1, because if we were to let n equals 1, well then we're automatically adding a 4 pi to each of our angles here. So we've gone past the cutoff point, or your range, because of what they told us up here in the question. Okay, like I said, there is another example of solving trig equations in the chat as well. Okay, so you have another video there just to go through it. So we'll get this bit done nice and quickly. The diagram shows OAB, a sector of a circle of radius 7 with centre O. In the sector, that angle is given in radians, so our calculators are already in radians for the first part, and the area of the shaded part is 21. Find the distance from B to C. Okay, so we're obviously talking area here, and what we've got is a sector and we have a triangle. So the first thing we're going to do is write down our formula in the hope of getting some marks. Area of a sector is a half r squared theta. That's actually coming from page 9 of your log tables, and that's the one we use if the angle is in radians. We also have our area of a triangle is a half the base by the perpendicular height, or a half AB sine C, as we used in the previous question. So first thing I'm going to do is, we know that the area of the shaded region is 21 centimeters. So we also know that the shaded region is basically just going to be your sector minus, sorry, that should be a minus your triangle. So I'm going to fill in as much as I can here. The shaded area is 21. My sector is a half r squared. So look at your radius. There is my radius of 7. That's going to be 7 squared times your angle, and it's already in radians, so we don't need to worry about that. So a half times 7 squared times minus 20, or sorry, half times 7 squared times 1.2, and we're subtracting from that the area of the triangle. So we need to decide which, of these two that we're using. If we went to go with the half base by the height, I actually don't know the base or the height, so that's no use to me. So I'm going to use the trig formula instead. So that's going to be a half the product of any two sides. So we'll take the side OC, and we'll take the side OA, which is 7, times the sine of the angle in between, and that's in radians. And we're going to work out as much as we can. So we can put this whole thing straight into our calculator, and I think that should be giving you 147 over 5. And we'll put as much of this in as we can into our calculator. So that's giving us 3.262, I think. So 3.262, and you have your OC there as well. We're going to try solve this equation to get that OC on its own. So we have a couple of things to do. We're going to take 21 minus 147 over 5, and then we're going to divide that by the minus 3.262, and that should give us our OC. So you're just throwing that straight into your calculator. It's 21 minus 147 over 5, and we're dividing by minus 3.262. And that should be giving you a distance from O to C of I'm just going to leave it to one decimal place, 2.6. So this distance here, that's going to be 2.6. So obviously for BC, which is what they're looking for in the question, it's going to be 7 minus 2.6, and that should give you 4.4, and our units are centimeters. Okay, just with this part here, obviously all we've done there is we've subtracted the 147.5 from both sides, and then we have divided both sides by minus 3.262 to get our OC. Okay, so hopefully that helped you a little bit, and I really hope that this this flowchart at the very top helps you a little bit to understand and to work through trigonometry questions. Like I said, there's 2 really good and helpful videos in the chat. So yeah, hopefully that was of some help, and I'm looking forward to seeing you next time. Thank you.